Alright, y'all. Today we're going to figure out which graph we need to use. Over the past few weeks, we've learned about distance over time graphs and speed versus time graphs. Now we're going to sort of compare the two graphs and figure out which graph is best for a given scenario. But first, shout out to the 100%ers from yesterday. Only had exit tickets because of the fire drill from UConn and Richmond. And in UConn, the 100%ers were Renike, Anijah, Justin, Cantrell, Terrian, Olavria. And in Richmond, it was Amy, Zaitia, Jalen, Kanijah, Nasir, Michelle, Ryan, Anna, Kanisha, Brianna, Amaya, Raphael, Elsie. Again, if you have trouble on your exit ticket, please come up to me at the end of class and I'll be happy to help you. What are we doing today? Our essential question is, when do I use a specific motion graph? Our lesson objective is we will analyze when to use a distance versus time and a speed versus time graph. And our homework, as always, is to finish the packet. Note number 1, we use a distance versus time graph to track the motion of an object from a start to an endpoint. So I know that if I have my distance versus time graph, I'm tracking the motion from where it starts to where it ends. Note number 2, we use a speed versus time graph to determine if an object is accelerating, decelerating, or at a constant speed. So I know that my object is accelerating from O to A. It's at a constant speed from A to B. From B to C, it is decelerating. From C to D, it's stopped. From D to E, it's accelerating again. And E to F, it's at that constant speed. Note 3, in a distance versus time graph, a steeper slope means that the object is moving faster, and a flatter slope means that the object is moving slower. So I know that my fastest line is the green line. Why? Because its speed, its distance was 4, divided by its time, which was 1. So 4 divided by 1 is 4 meters per second. And our slowest line was the red line. And this is the flattest line because its distance that it covered was only 1 meter, and it did it in 4 seconds. So 1 divided by 4 is equal to less than 1. It's 0.25 meters per second. Our practice question 1. Anna is trying to walk home from school. However, he forgets his life binder and has to turn around and go get it. What type of graph should he use? Should he use a distance versus time or a speed versus time graph, and why? Practice question 2. Jose is racing Luis to the end of the hallway. Jose always beats Luis to the end. Which type of motion graph should we use for this scenario? Should we use a distance versus time or a speed versus time graph, and why? And practice question 3. Draw a line in your paper representing Jose's motion, which was fast, and Luis's motion, which was slow.